Good morning and welcome to 2:20 on Monday morning. We are on week 11. Cannot believe it. On Canvas, that looks like this, where we're going to talk about data fields and methods this week and get a little more practice with creating our own classes. We're going to learn some more details about how to do that effectively. But today I want to spend some time kind of in a show and tell mode where I know several people asked to see my Hawaiian phonetic translator code. And so we're going to look at that. And we're also going to look at Battleship code, news you can use as we are headed into the progress check for that. That's due on Wednesday evening this week. So let's look at the Hawaiian program first. That was like a long time ago, and they are actually graded now, so you should have comments on yours in Canvas. And maybe I should demo what that looks like. Some people have trouble finding that. So I need to be a student first. Okay, so now I'm a fake student. So if I go to my course grades and then click on Project 3 Final Code, we've done a lot of work in this class. All right, here we are. If I click on the, of course, I can see my score in there. And then if I click on the little speech bubble, it gives me some details about the overall kind of project. And so for a lot of people, they had maybe like a few little tiny edge cases or something where it didn't always give the right output. And so if you had any of those, I listed those in there in the overall comments. Just so you can see, like, what was I testing it with when I found out that this loop didn't work right, or that you didn't handle vowel combination or something like that. And then if you click on the scoring details, you can see, like, I think some like breakdown of like how your score was compared to other people's scores. And then finally, if you click on the little like checklist, that gives you the grading rubric. And in there, you can read why you lost points. So it'll say something about like, this is what I was looking for over in the far left column. And then this is my feedback about that criteria for you. And then that's like how many points you earned on that particular checklist item. So you guys can check out those feedback. But again, what I wanted to share with you mostly was about my own solution for the Hawaiian translator. And I don't claim that there's anything particularly magical or efficient about my solution. It may not be that much shorter than yours, depending on how you approached things. Mine ended up being, I think, 120-ish lines. Blah, 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 blah. Oh, a little bit longer than that. 130 was mine with the comments and everything in it. So kind of how I organized my code, I had like my scanner at the beginning. We all had to have that. And then I had my big loop going around the outside that says, like, if they want to go again, so if they didn't answer no or N or anything negative, then we wanted to keep going. And then we asked them for their Hawaiian word. And then read that in using the next line method. The next line method was important. If you didn't use that, then you weren't able to process the words with spaces in them, because if you just use the next method, it stops when you see a white space rather than reading the whole line. Then I had a method that checked to see if the word that they entered was valid, if it had only valid Hawaiian characters. So I checked to see if it wasn't valid, then I printed out a message. If it was valid, then I wanted to start building the phonetic pronunciation for it because I knew there was one. And so to build my phonetic pronunciation, I needed a loop that iterated through the string for each of the characters in there. So I started this count controlled loop and a blank phonetic pronunciation string so that I could start from scratch with each new word that they entered. And then I checked to see if the letter that I was currently processing was one of the simple letters, or the simple letters are the ones where it's like most of the consonants where you see a P, you pronounce it as a P, you see, I forget what other letters were valid in Hawaiian. My method's down here at the bottom. So it was the P, K, H, L, M, N spaces and the apostrophe. Those were the ones that were simple characters. If you saw any of those in the word, you just added that to the phonetic pronunciation and you didn't have to do anything else with it. So those were like the easy peasy things. So if it was any of those, that would make my is simple method true. And then I could just add that same character to my phonetic pronunciation. It was only the vowels and the W where, it depended on the situation, right? Like it might be pronounced one way, but it might have a different pronunciation, and it depended on the context, like what came before it or what came after it. So for each of those special cases, then I had an else if. So if it wasn't one of the easy letters, then it must have been one of the hard letters. So if it was a W, then I realized that there's two ways to pronounce that. Most of the time you said it like a W, but occasionally you changed it to a V, and you changed it to the V anytime that the previous character was a I or an E. So that's my if statement in there. So if I'm not at the very beginning, if it's not the first letter, then there must be a letter that came before it. And so I can look at that letter that came before it and see if it was an I or an E. If it was either one, then my pronunciation's a V. And then I'll just add that to my pronunciation string. So if it wasn't a simple letter that was all the consonants plus the space and the apostrophe, except W, which I just handled right here, then it must have been a vowel. And the vowels were the cases where you had to add a hyphen after it, unless it was the next character was the end of the string or a space or a apostrophe. So this else is like, I might need to add a hyphen after it. And then I just have an if block for each of the possible letters. So if it's an A, what are all the possibilities? If it's an A, it might have a letter that comes after it that changes it to be an I pronunciation, or it might have a letter that comes after it that makes it an ow, or it might not be either of those. It might just be a regular A, and then you just add the regular A pronunciation in there. Anytime that I have to look at the character after the letter, I have to check to make sure that there is a character after the letter. And I did that by adding this test while currents not equal to the word length -1. So make sure that I'm not going to go out of bounds if I look at the character at the current position +1. And again, I just like lumped together the combinations that went together. So if it was an I or an E, then it made the phonetic pronunciation an I. And then because I've processed both the A and the character that came after it here, I have to add an extra 1 to my value of current to move over and skip over that I so that I don't process it again. And then the pattern was the same for all of the other letters. If you could do it for an A, then you could do it for the other characters as well. The E had 3 possibilities, 2 different combinations, and then one that was a single default. And then the I had 2 pronunciations. There's one combination option, and then one that was the regular pronunciation. O had 3, 2 combinations and 1 regular. And then U had 2 pronunciations, 1 combination and 1 regular. And then finally, after I had processed that, that meant that I was done processing whatever vowel was in there. And so the only thing I have to decide is, do I need a hyphen right now? Am I at the end of a syllable or not? And after each vowel, you end the syllable unless you're at the end of the word or there's a space or there's an apostrophe. And so I checked to see if I was in any of those special cases. And if I wasn't, then I added the hyphen, the dash. Then I just move on to the next character, keep going while there's more characters in the word, just repeating that over and over again. After you get to the end of the loop, then you can print out the pronunciation, ask if they want to enter another word, and roll on for the next iteration. So that was kind of my main program. The two methods I made one for, is it a simple letter, something that I just need to like slap that right into the pronunciation. There's like no combinations that I need to consider. It just returns true or false based on what those letters are. And then I made another one to check to see if the whole word is valid. And I called my is simple letter from in there. So I used my is simple letter like in my main loop, but I also used it in here to see, is it one of the valid characters? And that was it. Do you folks have questions? Anything about my solution? I know some people wrote about it in their project reflection, but I think one of the key elements for success on this project was starting small. Like if you just sit down and try to write a whole phonetic translation program and then test it, you're going to make yourself crazy. You want to start small with like, can I make the loop that just asks if they want to enter a Hawaiian word and reads the yes, no, and keeps going and ends at the right spot? And then if I get that going, can I ask them for a Hawaiian word and then maybe write a loop where I just print all the letters to the screen? And then if I get that to work, can I write it so that it just processes one letter, like maybe the easy letters? And then maybe I build a method that tests to see like, is it an easy letter? And then do whatever it is that I need to do in those cases. And then think about like, how do I handle some of those combinations? I think I did the W first, and then you have to have that light bulb moment where you realize like, oh, sometimes I go out of bounds because the W is the first letter in the word and I can't look at what came before it. And so then that makes you build in those guard conditions to use short circuit evaluation. It's super handy. I bet you thought you were never going to use that when we talked about that way back on like week number 3. It's like super handy. So building in those guard conditions to make sure you don't go out of bounds in the array. And then after I did the W, then I think I did one of the vowels, and it didn't really matter which one you started with. They all end up being about the same. And then most students don't realize that processing the spaces and the apostrophe is really no big deal. It's just like processing the non-combination consonants. But that's like something that you can add in at the end. Mostly because if you're working with strings like that for the first time, you probably didn't know what the apostrophe character was, which makes it hard to test for it. All right. I don't see any questions. If you guys do have questions, feel free to send me email or you can stop by office hours. We can look at stuff. All of that is very cool. All right, so then we want to look at some stuff related to Project 4. Trying to find it on my screen. All right. So Project 4, the progress check is due on Wednesday this week, and then the final project, it's due next week, but I put it up already so you guys could start looking at it and get it on your radar sooner rather than later. And so what are you supposed to do by the mid-semester project progress or the midpoint progress check for this one? You're supposed to complete the hide ships method of your JSmith Battleship player file. So I think I have mine pulled up here. So let's take a little tour of things we need to know. So one of the first classes that you need to read through is the board class, and that's why the labs and the project plan really focused on like reading through and understanding that particular file. If you turned in your plan last week, then in response to that, I posted the correct answers to all the questions that were part of the project plan. If you didn't turn yours in yet, you could email me a project plan and still get access to that same information. So if you're having trouble understanding it, again, just give it a good shot and then come ask some questions during office hours. That's totally cool, normal. So from reading the board class, we learned that we're going to have this game board and it's going to have 10 rows and 10 columns. It's the height and the width. It's going to keep track of whether or not each player has gone in this particular turn, and it's storing that as a variable called fired at this round. And that's false if you haven't taken a shot yet, and true if you have. So it just keeps people from cheating and trying to be like, oh, it's my turn. Oh, wait, I'm going to take like 10 shots at your board, and you're just going to be playing by the rules and take one on mine. And then I'm obviously going to win more quickly. So that just prevents that type of thing from happening, in case anybody had ingenious plans to game the game. And then there's some additional data fields in here. They're kind of like in a strange spot. Usually data fields are at the top of the file. Some people were like, oh, it's just those ones that are at the top, the 4 variables. But there's actually a couple more in here. They're buried in the middle of the file. And then you need to be able to call the board class's constructor so that you can make your game board. And to do that, you need to pass in a 2-dimensional array of characters. It checks to see if those characters make a valid game board. If they don't, then it just ends the game right away by throwing an exception. If it is valid, then it gets set up with this fired squares method that it uses to keep track of like how many squares on your board have been uncovered and how many of your ships are still left standing. That's all in there. And then it has a method fired at that takes the actual shot at that particular row and column and returns the value that's in that particular square. So if somebody says they want to fire at your row 1, column 2, it'll go to that square in the game board 2D array and then return the contents of that array. It'll either be a space or a ship. And then here's those 2 other variables that are buried here in the middle. Squares, that's the name of the 2D array that actually contains your ships and the spaces. And then the fired squares contains true false values, whether or not those squares have been uncovered yet. And the game logic uses both of those in combination to figure out, like, is the game over? So all that good stuff's in there. And again, don't change anything about the board class. If you change anything about the board class, it'll make your project not work with everybody else's project when we try to run it as a tournament. You also don't need to change anything about the Battleship tester file. It already successfully plays a game and figures out how many wins each player has. Now, if you want to change the value of like max in here so that it plays more than, I think it's set up to play like 3 games. Yeah. If you want to change the value of max so that it plays 300 or 3,000 games or something, that's totally fine. But you don't need to change anything about the game logic. Again, it already successfully plays a game. The one file that you need to edit is the JSmith Battleship player. class, and that one contains 3 different methods that you need to write. So that's where all of your modifications come in. So one of the first things you're supposed to do is change this so it's your name instead of J. Smith Battleship Player. And to do that, I would do this. I would say like K Anna Walt name underscore Battleship Player. And then I would say I want to rename this file because I don't want it to be J. Smith Battleship Player. I want it to be my name, K Anna Walt Battleship Player. So that was in the refactor and then rename file as the option. And then you just hit refactor. And ta-da, now yours is called whatever your name is. And that's all you need to do to make that work, and it'll still all compile together. Oh, in your Battleship tester, you need to change it so that right now it says like make objects of type Battleship Player. You can see that it's like angry. You have to change that so it's your name in that file. It's like still red. I'm going to try to compile it anyway because I think it's going to work. No.
Don't you have to change on the top where it says import Battleship Player? And then it says,
Oh, yeah. Okay, let me try that first. I was like, maybe it's like complicated. You guys are so smart. I do remember it like stays red for some people. Yeah, but it's like compiling and everything together. So when yours stays red, don't panic about that. Sometimes people send me email and I'm like, yeah, but if you hit compile, does it work? And they're like, oh, yeah, actually it does. Oh, wait, I spelled my name right and now it's all fixed. Yeah, excellent. All right, super duper. Good tip. I'm glad I was bad at typing this morning so we could see that. I definitely get email about that every time. All right, so we got our Battleship Player file that I've now renamed to be my name. And again, that should be like an easy peasy switch where you just rename it in your class file, then say you want to refactor and rename your file. And then your Battleship tester will have red underlines. And we solved that by changing it so that our, where'd it go? We did the import of our file instead of JSmith Battleship Player. And then on the 2 lines where we declare the players, we had to change it so that it used our new class name. All right. So now we want to focus on like, what do we need to do to fix up this Battleship Player file so that it actually does something and plays the game. So there's 3 methods in here that you need to complete. The first one's called hide ships, which just means place the ships on the board. So it can be like hidden. You can't like bury them in sand or anything. This is like a computer program. And so you'll be able to see your board, but the ships will be hidden because you've placed them on your board. It's just kind of like the step where you open the box and before you start playing a game, you take out all the little ships and you put them on your game board. That's what the hide ships method is. We'll need to fill in some code there. There's also called a method called go, and that takes your turn. So that's where you want to select a square to fire at and then take your shot. And then finally, there's a reset method that is useful at the end of the game. If you have like any variables where you like track things, some people get into like really complicated strategies where you're checking like what was my last turn's result and then like how am I going to use that to strategize to get the next turn. So things like that you might not want to have set when you restart a new game. And so you can like reset those all to the proper initial values in that reset method. Because in between the games, you won't be recreating your objects for your player. you'll just be starting a new game with the same object. So the reset lets you reset any of those values. So in here, in the hide ships method, that's what you want to write for Wednesday, just this one method. And once you write this one, your whole project should compile, and you'll be able to run it. It won't do anything interesting because you just made your game board, but it will be able to like create the game board and then print it out, and you'll be able to see it on the screen. That is a good goal for midweek. So what do we have to do in order to place the ships on our board? So it tells us up here in the comments. Reading the comments in this project is super key. So what does it tell us? It tells us hide ship. This is the method called once at the beginning of each game when you need to hide your ships. That means place them on the game board. And it tells us we have to return a valid board object. So we're going to be using the board class's constructor because that's how we make a board object. So we should read the board class for details about what that means and what happens when you create a board object. And then it tells us we shouldn't return the same board twice in a row. 2 successive calls to your hide ship methods always have to return different solutions, different boards to start with. And that's mostly for your own protection. There's like really crafty people who will code into their project something to remember the last game board. And then if you use the same board every single game, like by game 3, they're going to be like, well, I already know where all your ships are, and they can wipe you out in like the absolute minimum number of moves because they just remembered where you placed things. So having at least 2 different boards makes it sophisticated enough so that you can fake them out. And you stand a good shot at survival. All right, so we need to make this board object. So it tells me I'm supposed to put my code right here. First step is make a board object. And how am I going to do that? Again, I need to look at the board.java file. That tells me how to make a game board. And how am I making a game board? I'm calling the constructor because the constructor is the part of the class that sets up an object, right? Just like when we were making our student class, and when we called the constructor, it would make a new bundle of student data. And then when you made your movie class in the lab last week, you could call that constructor to bundle a movie object together. So this is going to be the same thing. We're going to create a board class or a board object. And so it's going to bundle together some data, everything about a board. All right, so we got the board classes constructor. There's just one option, so we have to call this version of the constructor. And it says we need to pass in a 2-dimensional array of characters, not strings, characters, to create our game board. Every once in a while, somebody like goes through all the drama of creating their game board and they used strings. And then when they try to call the board method, it doesn't work because it's not the right data types. So save yourself the hassle and create your 2-dimensional array so that it's characters. All right, so we need to create a 2-dimensional array of characters before we call the board object. Now let's think back into our recent past. Recent past, we have made a lab where we had a board that was 10 by 10. It stored characters, probably, although some people did use strings, which was totally fine in the lab. And let's talk about some things that were like the same and some things that were different about the game board that we created in class for the lab a couple weeks ago. So things that were the same, it was a 2-dimensional array of characters. We could print it out. You could print it out in your project if you wanted to. And when we were doing this in lab, we were creating an empty game board where we put like a dot in each of the squares to start out with. And then we ask the user for input about which ship do you want to place, how long is it, what's the XY coordinates, do you want it to be horizontal or vertical? And then after we got that information, we could use it to put our ship either vertically or horizontally on our game board using a little loop that went through for each character in the ship's length. Are we going to be able to do that same kind of process in this project based on what you know about like how the project works and like the level of user interaction? We're going to be able to do something like that to ask the user, like, where do you want to place each of the ships? Remember when we demoed the code last week and we looked at like, what is it going to look like when we run our project?
It's no, right? Because we're running against a computer.
Right, exactly. You're running it against somebody else's game, and neither of you is like taking your turn and typing in like row 2, column 4. I want to place my battleship. Um, Instead, your project has to like run automatically. And so remember when I was showing you like two different students battling against each other, I just hit a button and the whole thing went for like hundreds and thousands of games. And so there's not any user interaction. So we're not going to have this same kind of method that you created in the lab a couple weeks ago. This was useful for thinking about like, what does a game board look like? How are the squares of individual ships related to each other? Like if there is a battleship in square 2, 3, where else might the battleship be located? Has to be in like an adjacent square, right? Because the battleship's more than one character long. And so if there's one in that character, then the other part of it must be in one of those 4 characters. And then, of course, once you figure out the direction, it's like you can just go up and down that row to hit the other squares on that same ship. So this was useful for thinking about how a game board works and how ships are placed on the board and what that might mean in terms of strategy for your game. But it's not directly applicable. You can't just copy and paste this stuff and then dump it in the project, and that's not going to work. All right, so we don't want the input to be interactive. Do you remember anything we learned about when we talked about two-dimensional arrays that would let us make a two-dimensional array, but wouldn't be an interactive way of figuring out the data values for each of the squares? You guys can take a moment, dig out your notes for multi-dimensional arrays. Look in there, like when we were making a two-dimensional array, what were our options for creating one? Oops. So one mechanism was the one that I used in the lab, right? Where you could say like, I want to declare a new character array. I'm calling mine grid. You can call it whatever you want. And setting it up to have 10 rows and 10 columns. What was the other way that we could declare one?
Was it the static one?
I don't, go ahead.
It's like static final.
No, we use like the static final if we want to make a constant
Okay.
that like doesn't change value. And that goes like over here on the left side. Like what could we do to initialize this array if we didn't want the input to be interactive? It's in the notes for sure. It's like the alternative to saying new char brackets. Put stuff in them. If you find it before me, type it in the chat. So we were on the week where we talked about multidimensional arrays, and we had class notes about them for sure. And we learned that if we needed to just set up an empty array, we would use that first syntax option that I had. But if you already knew what values you wanted to place, you could just use curly brackets and include all the values that you wanted to place in your array in those curly brackets. So we can do that in our project. So I'm going to make an array of characters. I want it to be 10 characters wide. Now, what characters are valid in the board in the project? In the lab, we used a period for any space that wasn't occupied by a ship, and then we put the ship letters in the squares where a ship was placed. Is that the same as it is in the project, or is it different? Where would you go to look? Give you a hint. What method have, or what class have we been focused on when we're answering like all of those lab questions and the project plan questions? Which of the files represents information about the game board where we could go look to figure out what stuff am I supposed to put in the squares? Yeah, it's based on the board class because that's the part that controls like what does the game board look at and what's valid. And then when you look in there, remember there's that is valid method. That's a good spot to figure out like what's valid in my game board. I see that it has like check in to make sure that I have all these different ships, and I have to use uppercase characters for my ships. I'm lazy, so a lot of times I put lowercase in and then I like forget, oh, we got to change those all to uppercases. Then I have this call to has only legal characters. I bet that's going to help me figure out what legal characters are. And it looks like the legal characters on a game board are the characters representing the 5 ships and then a space. So I got to use a space in my program if I want to put an empty square on my board. Whoops. I got to use single quotes because I'm doing characters. And there's 10 of them going across each row. How many did I get so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. So that's 1 row of my game board. And then I'm going to need 9 of those. I'm going to copy and paste. Get 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one can't have a comma after it. And then I have to actually put my ships on there, right? So I got to just like pick some. So my aircraft character, that's 5 long. I'm going to put that in my top row. And then I'm going to put my battleship going down here. It's 4 long. And I have my patrol boat. That's the small one. And the submarine's going to be over here. Whoops. And then my destroyer, I'll put that like down here somewhere. Super. All right, so I just made a game board grid. And now once I have that, I can call my game board object. And how do I call the constructor? I just say the name of my data type board, give it a name, whatever you want to pick, and then say equals new board. That's calling the constructor. And then we know this constructor has to have a two-dimensional array passed in as an argument. I'm going to put that in right there. All right, so let's try out and see what it says. So it says, I'm missing a return statement. What do I need to return? You can figure out what you need to return by looking at the signature for the method that you're writing. And you're not allowed to change anything about the signature. Every once in a while, somebody tries to like make it so that this hide ships method takes arguments or returns a different data type. Don't do that. That makes it not compile with the whole project again. All right, so I'm supposed to return my board that I just created. Excellent. Let's see what it tells me next. So now it tells me I have an unreported exception. I have to declare or throw, catch or specify, right? And it tells me that it's from the board. That's why it's red and underlined. So what do I have to catch in terms of an exception when I'm making a board object? This is kind of tricky because we haven't done this before. It's good to watch. So it tells me that my board class constructor throws an exception. So, oh, I should have like realized that. And it throws the exception if the board's not legitimate, right? So if it detects that I have created a bad board, then it's going to generate that exception. So when I create my new board object, when I call the constructor, I have to potentially catch or specify. Now, if I specified it, that would mean that I just had to add stuff to this header line for my method, and I'm not allowed to do that. So I have to handle it. I have to use the catch option in here. So what do I want to do? I want to catch the exception if I'm making a new board. So part of what I'm going to need to do is separate my declaration from calling the constructor so that I can do that. So I'm going to say I want to try calling my constructor, and I want to catch an exception if there's one thrown. And I'm just going to make it print out something that's like, your board is invalid. Check your array. Because if you get an exception, it's likely because you either put only like 9 characters or 11 characters, something really close to 10 in one of these rows or columns, or you forgot to put in one of the ships, or you used lowercase letters or periods instead of spaces, something like that. So you just want something in there that like alerts you to the fact that like, oh, like whatever you're using in this particular example isn't the right kind of value. And then it's telling me that I can't return my board here. What's it upset about? I'll compile and it'll tell me. Oh, semicolon. Okay. So now it's telling me my board might not have been initialized. And that's the tricky step because we haven't done anything like that before. So it's telling me I have my board declared up here, but I didn't set it to any value. But then I'm telling it to return my board. So it's worried. It's like, hey, that might not have a good value in it. You need to do something to initialize that. So up here, I'm going to initialize my board to null. We've never done that before. It's just setting the board up so that it's initially undeclared or like not set to anything, but it's set to someplace reliable that Java feels okay about returning from this method. So I'm saying make a new game board that's null, and then try to make the board using my 2D array, my grid. If an exception gets thrown, it's going to print this message and it's going to end the program. And I know that. And so it's only going to return my board if it's the good board that I just made in my constructor call. So that's all going to be great. Ta-da! Once you have that amount of code in there, you should be able to see the game board. It's going to show you what's happening after each turn. And in my turns, it's not doing anything because I didn't fill in my go method yet. But you should be able to like go all the way back to the beginning. You'll be able to see like your initial game board. And remember that your game is playing like your player against your player. So they're both going to have the same game board to start potentially, unless you do something fancy in there. And maybe I should have made it so that it didn't print all the stuff. Still scrolling all the way back to the beginning. Man, I think it looped back around. I think it went to the beginning and then it started over at the end again. Oh, it's because it's playing multiple games. I forgot about that. All right, this might take me too long to scroll back, but you can see that each of the game boards is printing. And again, I'm not going, so it's not changing anything about the game board after each turn because I'm not even taking shots. You can see that my ships are placed exactly where I said they were going to be using my 2D array that I have in here. So it's a super basic method for my go or for my hide ships method. Now, can you guys stop there? Are you allowed to do like exactly this amount of work that I just did in my example for your project? Let's read our comments in here to see if we satisfied all the criteria. So it says this will be called once at the beginning of each game when you hide your ships. That's a thumbs up. You always have to return a valid board object. We set that up. And then it says you should never return the same board twice in a row. So 2 successive games shouldn't have the same game board. Is that true in my solution, or is it always the same game board?
Always the same.
Yeah, it's always the same. So you guys have to think a little bit about like, what could you do in here to make it so that it's not always the same game board? There's like a couple different solutions that are legitimate and not a ridiculous amount of extra code. One thing that you can do is keep track of like whether you're on an even round in the game or an odd round in the game. So you just need like some extra variables in your Battleship player file. And then if it's an odd round, use this game board. And if it's an even round, have a different game board, have like a grid 2 that you use to initialize it. It's totally fine. And you can have as many of those as you want, right? Like if you want to have 4 different game boards that you alternate between instead of 2, it's totally easy to set up. Just have like a grid 1, grid 2, grid 3, or whatever. You can also place some of the ships and then maybe use a random number generator to place one, like the 5th ship on there. To get a little bit of extra variety and unpredictability. You could randomly generate the placement for all the ships. That one is harder than it sounds because you have to make sure that all of the squares that you're picking stay in bounds even when you're placing the ships. And so I recommend doing like one of the basic ones first and then being fancy with the random number generator after you have it all working, if you have some extra time. In my personal experience, having a hard-coded game board like this and having at least 2 or 3 of them, it doesn't give you any less success in the final tournament rounds than doing something fancier with random number generation. So the random number generation, it's a cool idea. Definitely do it if you're like, oh, that sounds really cool. I think I want to do that. But if you feel like, oh, I don't know how to do that, or I'm not sure I have time to puzzle out a lot of details and troubleshooting, that's totally cool too. And I don't think that using a solution similar to this will have any impact on your gameplay. But that said, it all depends on your opponents, right? And what they pick as their strategies to defeat you. Do you folks have questions? Anything about Battleship you were thinking about when we were looking at the code in class? Nope. Let me stop recording.